Hello. Is my mic all right? Because some people usually complain that my mic's really bad. I just want to test that before we begin. Okay, I got a few messages that it's fine. Yeah, so welcome to the Web3 Development Workshop by NUS Fintech Society for the NUS Fintech Month workshops and hackathons. I hope that most of you have signed up and are participating for the hackathon, and that's why you're here. Uh, Good to see quite a few people um, joining. So just some disclaimers before we begin. I hope that you've attended the workshop by Colin yesterday, because this is gonna like kind of assume that you have that knowledge. I'm not gonna like, start explaining what smart contracts are. I'm just gonna go straight right into how you can code. That's our first question. I'm answering it live. How can I code on the blockchain? Yeah, just watch it for an hour and find out, I guess. Um, yeah. Um, yeah, so I hope that you can feel free to stop me and ask some questions if you don't understand, but I'm gonna assume that all of you have attended the workshop yesterday. So I'm not going to be explaining more of how it works kind of thing. I'm gonna be explaining like how you can do it. Wait, what's this? Okay. Go to the next slide. Yeah. So again, it's just a quick slide to explain like the difference between Web 2 and Web 3, because most of you must have developed like something or the other in Web 2, right? Maybe a simple website or a server or an API that um, sends some data to your front end, things like that. So I'm pretty sure that most of you have done that. So just a quick like history session here. So Web 1 was the World Wide Web, early to late 90s. When things like Yahoo and search engines indexing, it was just a place where people could go and read and gain knowledge. And the data it wasn't written by the users themselves. It was written by corporations or universities for research papers and educational material. Um, yeah. And then came Web 2, which is what most of us are probably using today. It is like the social media era, Facebook, YouTube, where the content is itself is user generated. So like you're the one who's posting the videos on YouTube for others to watch, right? Yeah, your Facebook posts, your Instagram posts. The content on Web 2 is primarily user generated, and then there's Web 3, which is also known as the token economy. Um, Web 3 is where, I mean, it's obvious that Web 3 can do everything that Web 2 can do. Maybe not scale as well, but users can now execute their own code. Sure, in Web 2, you can write your own server and then you have to host it somewhere. So you're not the one who's executing the code. And there are some restrictions, right? Like, let's say you put it to AWS. One day, AWS can just say, oh, Amazon is launching a product that's competing with yours, so we're going to revoke your AWS license or whatever. So it's not you who's executing, it's mostly the big corporations who are in control. So now anybody can execute code with the help of blockchains like smart contract, like Turing complete blockchains like Ethereum and some others. Um, yeah, so that's basically the difference. So we're gonna learn how to code for Web3. There are other things that Web3 can do, like sending and receiving money is much easier than it is in Web2 because of crypto and the like coins like ETH and things like that. Uh, yeah, so that's basically an intro to Web3. I hope nobody's confused here. This is just like, oh, we're in the Web3 era. It's not something that's like you don't need to go to like Tor or something to use Web3. Yeah, just. Okay, so coming from Web 2 to Web 3, there are quite a few changes in your tech stack. So the front end, the actual front end would mostly stay the same, like whether you're using React or Vue. So that wouldn't change as much. You can always deploy your Web3 app to like on like Heroku or Vercel or anything, that's fine. If you want to go to the extreme and be like, I'm 100% decentralized, you can deploy on IPFS, the uh, uh, interplanetary file system, I think. So it's like a file system that's completely decentralized. You can deploy websites on there, and you don't need to rely on the centralized servers. But that's just an optional thing. So the front end, the actual code that the API, however, would change. You usually would write your own backend server and just call APIs uh, in the front end, right? But now we need to use some special tools. Like for example, JavaScript has Web3 JS and Ethos JS. There are libraries that interface with the. So these are libraries that actually interface with the blockchain. So instead of connecting to a centralized server, they're actually connecting to a chain, right? So that's what you use. You use Web3 or Ethos JS to connect to the Ethereum chain. There are some other libraries for other blockchains, and there are also then other languages. Like let's say if your front end or your client is in Java, you can use Web3j, things like that. So the API which you use to interact with your chain would also change, and the backend would mostly be written would you need to convert most of your, at least your critical logic, into smart contracts that can then be deployed on these blockchains. So we will look at how, like, what happens when you deploy a smart contract, where is it run? We'll look at that a little later, but um, uh, yes. So the backends would be converted to smart contracts, but it's not to say that it has to always be on a smart contract. There are some things that do not need to belong on a smart contract, because there are some downsides to using smart contracts. So you can still use like a traditional database or a backend or a server in like conjunction with a smart contract. And smart contracts are usually written in Solidity. There are some other languages for other chains, but we're going to be focusing on Solidity for uh, today's workshop, and I'm presuming for the hackathon as well. Most of our projects run in Solidity. Um, yep. So again, I'm gonna talk a little bit about the technical side of how contracts were, like what happens when you call a smart contract. Um, what happens when you deploy a smart contract? Why is it a smart contract run and things like that? So I'm just going to make use of the screen right here. So you are the user. You're now a Web3 guy. So you're not going to be deploying, to AWS or something. So then there's this is the blockchain. So the way you connect to it is RPC and some other APIs like Web3.js, but this is the blockchain. And the blockchain is made up of different nodes, right? I hope that these kind of concepts that you're familiar with from the previous workshop, but yeah, so these nodes on the Ethereum network and some other networks like Binance Smart Chain, Polygon, they all have this virtual machine running in them called the EVM. EVM stands for the Ethereum Virtual Machine. So you don't need to be an Ethereum network to have an Ethereum virtual machine. So you can technically deploy EVM smart contracts like Solidity contracts onto other non-Ethereum chains like Binance Smart Chain, Polygon. They're all EVM compatible. I hope that's not confusing. But the EVM is still called EVM, so it's called Ethereum Virtual Machine. Then you kind of detach the concept of EVM and the concept of Ethereum, the network. I hope that's clear. So this can be any EVM chain. We're only going to focus on EVM chains today, but most of the chains work in a similar way, just that we need to write the contract with a different language or library. So each node has EVM, and this EVM is basically like your JVM, like a Java virtual machine. It can run code, which is written in EVM bytecode, like JVM bytecode, Java bytecode. So what actually happens is you write your contract, right? Your like core logic, the backend logic, and then you compile it to EVM bytecode, and then you deploy. So once you're deployed to the chain, everybody here has a copy of your EVM bytecode. And then when you kind of call the API or you call the smart contract, one of the nodes, whichever the nodes who's mining, and some others just to verify, like validators, they run the code. So they run your code inside the EVM. So they run your code. Let's say it's like if I give a number, you return a number plus one. Something really simple. There's no way I'm going to do that on prod, but yeah. So then this will be like, oh, I'm running x is equal to x plus one, or something like that. And then after that, it would return the code back to you, like it would return the result or whatever, and it would only the nodes run it because they are the ones who are mining the transactions. Yeah, I guess that's a simple way to put it. It's a little bit more complicated than that, but so the nodes run the code and then they return it to you. That's it. So I hope it's clear where your chain is being run. It's being run on somebody else's computer. So these are just like normal computers of people. I mean, they may be of like huge corporations trying to mine Ethereum, but they are people in an ideal decentralized world. So instead of your code running in an AWS server in Iceland or something, it's being run on somebody's computer, which is connected to the Ethereum network, which has the EVM. And the code is run on EVM. It's not run like on the computer itself. There's some security reasons and some other change-related reasons why this is designed this way. Yeah, that's how smart contracts work. I also like to quickly talk about the message object because that's important when you're coding out smart contracts. Because so on your like traditional backend server, you'd probably have like an auth service or something that authenticates that, oh, this person is this user, so he has access to this. We should query the database with this user ID, things like that. But on Ethereum, everybody has an address. Most people do. They have an Ethereum address, and this Ethereum address has a lot of things. You know, they're like ETH balance, private key, public key, the other like ERC20 tokens. ERC20s are not stored in the address, but for simplicity's sake, maybe as but from the UI point of view, it looks like this address has the ERC20 tokens. Then your contract. It'll have some functions, right? It'll have a function that does something, but maybe you want to check who the user is before doing something, because let's say this user cannot withdraw some other user's funds, right? Yeah, that would be stupid. So what happens is when somebody calls the functions, they send something along called the message object. This is a global object that's available anywhere inside any of your functions. Inside the Solidity code. We'll look into the code later. So after like 15 more minutes, it's going to be all coding. Yeah, so the message object has a few things, like it has the sender, which is basically the address. It has a value. So each transaction can have some value. Let's say I want to send some money, right? I can add it into the value message and that money will be sent. And if the transaction succeeds, my Ethereum balance will decrease and the balance of the contract or wherever I'm sending this to will increase. So there are some other attributes like sender value. I think sender and value are the most important. There are some other fields, but like data, where it's actually hashed, but we don't need that for now. Yep. So I hope that that's kind of a quick rundown. I may be rushing things because we have a lot to cover in an hour. So you can ask questions in the Q&A thing in Zoom. Yeah. Okay, so we're going to get into Solidity with a syntax primer. So just to kind of introduce the keywords, things like that. So we're going to be using Solidity version 0.8. I think it's fairly new. Solidity keeps changing from time to time, so maybe you need to keep up with it. But yeah, so just a quick, these are all the types, the primitives that are there in Solidity. So there's a uint, which is an unsigned integer, which has no sign, so it cannot be negative. It can only be like 0 and positive. And then there's uint 8, 16, blah blah blah, and 256. So the suffix over here, the number, kind of indicates the number of bits that you want this uint to have. So a uint with 8 bits can store only values from 0 to 255. You may think, oh, well, then I just use 256 all the time. We'll come into why you may want to use some other uint sizes. later on. And there's a signed integer, which is new. I think it's new in 0.8. When I started learning Solidity, there were no negative numbers in contracts. Which may sound weird, but now there is. So there is integers which are signed, so it can be negative or positive. Do keep in mind that all these do overflow. It's just that when you have 256 bits, it may not overflow. What's the difference between signed and unsigned? Okay, signed has a sign, right? So when you write numbers, you can have a positive sign or a negative sign. So I can have +5 and -5. So the minus or the plus is the sign. So unsigned means it cannot have a sign. Yeah, as I said, okay, I'm actually answering a question from the Q&A if it's not clear to some others, but unsigned has no sign, so they cannot have a negative sign. So it's only the 0 and all the positive numbers which don't have a sign. Because when you write 5, you don't write +5, you just write 5. So that's kind of the rationale they use to name signed versus unsigned. But yeah, unsigned, they don't have a sign, so it's only 0 to blah, blah, blah. But signed can have negative numbers. Okay, let me just do this. What programming language you're referring to? So I'm actually talking about Solidity. It's a programming language used for Ethereum and EVM compatible smart contracts. So it's a language called Solidity. I'll get into the actual language in VS Code a bit. So I hope that will clarify things. And Nadia asked, is that kind of like absolute value? Absolute value. Okay, it is. I mean, as in, okay, imagine that all the numbers you can store are just 0 to positive. It's not like if you store a -5, it becomes a minus. It becomes a 5. If you store a -5, it'll actually become like 4 billion or 4 trillion because of the way the integers are stored in the system. But it's basically all the numbers that can be represented by the output of a absolute value. Yeah. Yes, that's it. So strings, as you're used to in other programming languages, it's just like text. So ABC, booleans is true or false. Key value pairs is like a hash map. So you have a key type and a value type, and if you put in a particular key of the key type, you get out a particular value of the value type. So it's a mapping from a list of something to a list of something else. Addresses. This is something new, which is not there in some other programming languages. So an address refers to an address of a user or a contract or anything on Ethereum. It's actually like it's 64. It's a 40 to, but it's stored as a 64, but it's a 40 byte hex address. So you can see like people have addresses like 0x ABC, 0x 1A 2C, something like that. So it's usually the address, and then the bytes 32. It's just a way to store 32 bytes. So each byte can be a character or whatever, like however you choose to encode it. So it's used for like some kind of advanced types. Encoding, hashing, that's all you'll probably encounter with bytes 32. And types are arrays. I mean type and then the square brackets. That's just how you initialize an array. Yeah. Don't worry if you like can't remember all this or if it's going too fast. The code will hopefully make sense. I'm just trying to like brief you before I go to the course, so most of you can at least understand what's going on. Structs. Structs, they're like C or C structs. Yeah. It's just a way to have multiple types packaged in a single type. So this new type basically has this member, this member, and this member. So it's a new data type that comprises of some primitive data types. And this is the way you initialize arrays. So the type of the array, the name of the array, and then the array size. And then you have enums also, but I don't think that's really relevant for today's discussion. Mappings, I have covered them before. They are like Java hash maps or hash tables. Basically, it's a key value pair. So you have a key and a value pair. And then if you say like mapping name of key, right, you get the value associated with this particular key. So I can have like A is 1, B is 2, and C is 3, right? Let's say I have this. So if I put mapping of, if I put like the name of the mapping, which is like num, okay? If I put num of A, it should give me 1. Like a dictionary in Python, yeah. Okay, loops and ifs, very similar. I hope the syntax is, it's just syntax, the core idea you should probably get from some other languages. So this is an if, so if condition, else if else. I hope like if this is true, it executes this, otherwise it executes this, otherwise it executes this. A for loop, so you can have a, it's similar to the C++ or JavaScript. So you have an initialization and then a test condition and then an iteration. So it does this first and it goes to the loop, and then it does the iteration, the test condition, and then goes back like this. And then it stops in the test condition, fails. Then while condition, so as long as this condition is true, it executes this. Do while is similar to while, except that it executes first and then checks, while here it checks and then executes. Again, this is like if you've coded before, you'd probably be familiar with most of these. It doesn't really matter if you don't know them. It's just like you'd get used to them once you write some code. And then functions. Functions, you declare a function by using the keyword function, and then you use the name of the function. And then you have the parameters, which is the input to the function. Modifiers we'll probably cover later. Like you can change how the function behaves. Returns, and then the return type. So function and returns are keywords, so you have to use them. Function name and return type, parameters and modifiers, you can change. So an example is this function over here. So this function has a keyword function. Then the function name is f. The parameters are two uints, unsigned integers, a and b. These are the modifiers, public and view. I'll explain those later as well. Returns, just a keyword, and then returns a un. So this could probably be like an add function. So here it would be like return a plus b. So it will take two u integers and return a u. Yeah. So that's how functions work. Yeah, I'm just going to talk a bit about access modifiers. You can just feel free to stop me or ask some questions if it's going too fast. But I may be running out of time as well. So that's why I'm rushing. So function access modifiers, they're similar to like the access modifiers in Java or C++, where, you know, a class, if you're outside a class, maybe you cannot access the private members, you can only access the public members. Like that, similarly, we have public and private. So public can be accessed from outside and inside. Private state variables and functions that are private, they are only accessible inside the same contract. We have external and internal, similar to like public and private. External can be accessed from only outside. So you cannot access an external function from inside the same class, the same contract. Internal, likewise, can only be accessed from internal, only inside, but it cannot be accessed from other outside contracts that are trying to call. So the difference between internal and private is that other contracts, like for example, let's say you have a code and then you have some other code, another server or another API that's trying to call this. So if this code derives can be called, but private can only be called inside the contract. So it's internal, as private is like strict, internal is a little lax, but still strict. Yeah, this may be complicated because you don't know what deriving contracts are. Just remember that private is like only inside your contract and nobody else can ever access the code. External is only for humans. So external is when your user or an address that's not a contract wants to interface with this. Public is, well, anybody and everybody can access it. Yeah. Okay. So I need to explain something that's pretty important before we go to the code, which is gas. Okay, so let's say we had the network again, and then there are nodes running the contracts, right? The thing is, people are running on contracts, and usually for AWS, you pay fees, right, to deploy the code and like for usage. But it's not like it's free on the Ethereum network. You still have to pay, but it's just that instead of paying AWS, you're paying whoever is actually running your code. So you're actually paying them, and that's what gas is. So if your contract is super long, right, and you need to execute like a 200-line function, that's probably going to cost more than a 50-line function, right? More code, more electricity and like things like that it needs for the node to run. So you have to reward the node a bit more because you're running more code. That's what gas is. So most likely you would probably need to optimize your contract to make sure that it's cheap and super fast and easy to run so that your user doesn't pay a lot of fees, gas fees. That's why if you see like a lot of gas fees, it's probably that the contract is very poor or you're doing a lot of complicated stuff. And so the gas fees is high. That's really simplified. So just make sure that your contract is super clean. It doesn't waste resources or memory or instructions. There are some special functions called pure and view you might have seen before in the function example. So these functions actually cost 0 gas because they're not executed as a part of a transaction. So you can it's more analogous to a GET request in a server. So pure view functions are GET requests, and then you have like POST requests. Those are normal functions. So GET requests are just querying. You're not changing anything. All you're doing is querying the data, get data. So those are kind of free. But if you need to change the data, like if you need to write to a database, you need to use a POST response, right? Like that you need to use functions that are not pure or view. And so you need to pay gas for this. So basically, you need to pay gas whenever you do something that changes the state or that writes to the database. And it's 0 gas if you're not writing. So that's something you need to listen as well. There are some custom modifiers. This is also something that's a little advanced, but so let's say you have a function here that's like register. You can have so these are modifiers, right? Public is a modifier. Like that, you can have your own modifier called costs that runs some code. So let's say you want a user to register, but you want to register only if he sends you more than an amount. Only if he sends you more than 10 ETH, he can run this function, right? So he must be like an elite member, or he must contribute a lot to your contract. So you do this. So in this case, if the message value or the amount he's sending is greater than the price, then you execute the code. Otherwise, you don't execute. So this underscore is basically like execute the function that's here. So that's what it means. So you add the modifier here, like for example, only owner. So this modifier only owner, right? It makes sure that the message sender is the owner. Don't worry if this is complicated as well. We're looking at the code and hopefully that'll clear some things. So only if the message sender is the owner, this guy can run the contract. So nobody else can run the function. Yeah. Just one last thing to cover before we start. Stateful architecture. This is how the contracts are usually written. So each contract will probably have some code over here. It's the functions that the users used to interact with, and then it'll have memory. So this memory is the state of the contract, and it's like a persistent database. So the memory will always be there, and then these functions will most likely change the memory. So they're like state. So you start with the state of a contract, and then you have a transition, which is a function, and then the function changes the memory, and then you have a new state. So that's usually how you think about the way you design contracts. So state, a function that changes the memory, so it's a new state. So initially, if the memory was 1, the function changes it to 2. So 2 is the new state of the contract. So if you kind of have some other functions, it will react in a different way. So the payable keyword is what you use to send and receive money to functions. You don't need to use Stripe or any complicated API. All you need to do is add the payable keyword to your function, and now the function can receive and send Ether. Yeah, so that's about it. One last thing is that there are no floats in Solidity. So floating point numbers like 1.2, you cannot represent that. You need to use some tricks like having a super long integer and then place so let's say you want to represent like 1.23, right? What you'll usually do is you'll save 123 in a uint, and then you'll be like, oh, this has 2 decimal places. So now I will place a point here, whatever the number is. Let's say it's 456. Whatever the number is, I will place a point here, and that's the number. So this is how you represent floating points. Yeah. Okay, so I'm just gonna. So I'm gonna start looking into the code. Let's look at something simple like the admin control. So this is a contract. So welcome to your first Solidity contract. So all Solidity contracts end with .sol, and then the name of the contract. So admin control will have a file name admin control.sol. So the way you start a Solidity program is by mentioning the version name. So this tells the compiler, oh, I'm using version 0.8.6 and above of Solidity. So this code is compatible with any compiler that can compile 0.86 or above. So you can use features that you cannot use in maybe 0.66. Yeah. Yeah. Okay. I don't know if I've changed that, but yeah. And then you start your code, and all your code is written in a contract block. So the contract, the name of the contract, and then you have a block. So all the code is written here. This is similar to a class if you're used to Java, but no worries about this. So this is a contract. So this is basically, it has some state, it has some functions that act on the state. Yeah. And then a constructor, this is only called when you're deploying the contract for the first time. So what it does is you can have some kind of setup work or initializing the state to something you want. So what I'm doing is the constructor, it takes in a list of addresses, right? So this is the constructor, it's a special function. And then there's an input to the function. There's no output, does not return anything. Constructor does not return anything. And then there's a function block. So the constructor takes in an address array. Again, you don't need to worry about the memory. He would just use memory for most of your function inputs because they cannot be storage. You probably wouldn't need to use storage unless you're calling contracts from other contracts. But yeah, so a constructor will always have memory anyway. So address, a list of addresses, and then the name of the function, name of the thing. So once you're inside here, you have an address list. And then you can say like, oh, I have this state here, right? So this is the data member of the contract and the state of the contract. This is permanent. It will always be like this. Yeah. So now we set the admins to this. So basically, whatever the list you pass in, it's now stored as a member inside the persistent database or the memory of the contract. So let's say if I pass in address, maybe 123, right? Now this list will now have will now have 123 over here. And then I'm doing a dot push. Again, these are just functions that you use to interact with your list. So this appends to the end of the list. So remember, as I covered before, message object has a message dot sender. The sender is whoever is calling the function. In this case, it's whoever is deploying the contract, because it's a constructor. So I'm also adding whoever who deploys. So let's say 0456 is the one who's deploying. So now the array becomes 456. So it has 1, 2, 3, and then comma, and then 456. So it has 2 elements. Yep. So that's the constructor. And then we have a state, which is the storage, and then we have a modifier, which is similar to the modifier we saw. So I'll just briefly talk about what this modifier is doing. The name of the modifier is only admin. So you can see that you have to add the only admin modifier to some functions if you only want the admin to use the functions. So basically, if you're familiar with programming, you can see that I'm just checking if the message.sender is inside this list, first inside this. Okay. Now, this is probably another keyword as well, which you really need to know. So require is basically like an assert statement. So you require that this, it's a Boolean, so it takes in a Boolean. So I can just say, things like, oh, message.sender is 456, or like this. So I want to say that, oh, the message sender is 456, or something like that. Okay, the way you do it is address. Gonna give me some errors unless I do that, but yeah, just to get your point across. So maybe, okay, now only the 456 address can. It should be true, right? So if the message sender is not 456, it will quit. It will throw an exception, or it will just quit the transaction, and the transaction will not execute. Even the code here will be reverted. Whatever I wrote, if I change my state, that would be reverted as well. So it will be like the contract or the call never happened. Yeah. So it just takes in a Boolean. If it's true, it will continue. If it's false, it will panic and quit and just act like it never happened. Yeah, and then this again just goes to the code. So yeah, so we have a function here that adds an admin. So it takes in an admin address. It's public, so anybody can access it. it's public, but only the admins can access it. So public, anybody can call the function, but only if you're an admin, you can add it. Only if you're an admin, you can add other admins. That makes sense. You don't want anybody to add an admin. So only if you're an admin, you'll enter this. So once you enter this, you can do whatever you want. If you're an admin, so you can delete and add into the admin array, right? It makes sense. So you add whatever admin you want to pass in. So let's say I want to add my friend as an admin, and I'm already an admin, I can do that. And then this function is a getter function. You can see that it's a view function. It costs 0 gas because I'm not changing this. Notice that I'm not changing the admins. Here I am changing it because I'm pushing it. I'm adding a new element to the list. But in this function, I'm not changing the state. I'm not changing the storage. So I can have it as a view function and it will cost 0 gas. Yeah, so it's an external function. It's a view function, so it doesn't cost any gas. So anybody can call it, but as in anybody outside the contract can call it, but it's free to call, and it returns an address list. So it just returns this. So you can see it returns address. So that's a really simple contract. So this is your first Solidity contract. All it does is you can add admins, and only admins can add the admins. And anybody and everybody can see who the admins of the contract are if you want to contact them to be added as an admin. A really simple contract. I hope that you have understood the contract well. If you haven't, please ask a question. I'll probably wait for a second or two before going on to the next contract. Okay, I don't see any questions. I kind of zoomed in to show show everybody, but this is a full contract zoomed up. Yeah. So again, this is the constructor. It initializes the contract. This is the state of the contract, or the storage state, or the persistent DB from wherever you're whichever kind of paradigm you're coming from. So this is like a variable like that you just connect to by calling using the name. Yeah. And then this is a modifier. Yeah, all it does is checks if you're a part of the admins list. And these are the functions. So these are like the API endpoints that your client or whoever wants to interact with. So this is kind of like a post request since you're changing the state. And this is used to add an admin. And this is kind of a get request. Because you're just accessing the data, you're not really changing the data. Yeah. I think if I do try to make this a view, it should give me some kind of error. Yeah, function declared as view, but this expression potentially modifies the state and thus requires non-payable or payable. So you cannot have it as a view function because it changes the state. Yeah. This can be a view function. I think, in fact, it will even complain if it's not a view function. Function state mutability can be restricted to view because you're not changing the state. Yeah. So I hope that's fine. So let's get into something a bit more complicated. Yeah. So again, this is just some to make sure that anybody can use. I'm pretty sure on like GitHub you would have seen, like GPL license or MIT license or unlicensed, like whichever one you want to put. Doesn't really matter unless you're like making a really big contract and you don't want others to use it or something. Again, the same version. This is also a new statement, so I'm importing another contract into this contract. Is there any non-code interface to build these smart contracts? Yes, I will come into deploying and building the contracts after I go into this. So we're actually going to be building and deploying the contracts I've showed here, if time permits. Yeah. So I'll show you the tool I have. I have a terminal set up here. But yeah. What? Oh yeah. So this is how you import a contract. So I'm importing admin control.sol. Um, and now this is also a new syntax that we have used. So contract NUS bank. So this is a new contract. So it's a bank contract. So it's a banking. That's the functionality of a really basic bank, and it's called NUS bank. It is an admin contract. So the is keyword is used to derive. So if I say a particular contract is admin controlled, right? I derive. I just instantly have all the functions that I have here in my new contract. And I have all the modifiers and I have the storage. So this NES bank, right? I haven't written, that it has get admins, but it does because I have extended from the admin control contract. So you can see that it calls admin control functions. There may be, there is no only admins. Yeah, but you can see the constructor also takes in an admins potentially if you need to do that. If you need to use that, this is just, it doesn't really make sense. Like you wouldn't want the bank to be admin control of this. I've just done this to let you know that you can do this. So you have a mapping here. So this is again the storage of the state of the storage of the contract. So storage just keeps track of the balances of all the users. So you have an address, which is the key type, and then UN256, which is the value type. So each address is mapped to a particular balance, which is their balance in this particular smart contract or this bank. Okay, you have a constructor here. All it does is call the admin control constructor. This is pretty useless. Yes. So the three main functions are basically a deposit function, which you use to deposit money, a withdraw function, which you can use to withdraw money from the bank, and then a balance to check your balance. Yeah. So I'm just going to go quickly through the functions here. So the deposit function is a payable function. So payable means I can use message.value. Message.value basically has the amount of money that's being sent in a particular call. So apart from just sending data, you can send money. So I can call this and I can send like 1 ether to this. And whatever money that I send here, right, the 1 ether will be stored in the contract. So contracts also can store money, just like how addresses store ETH. Contracts can also store ETH. They can store ERC20s. Contracts can basically act like humans, just they can store things. Yeah. So you can see that the compiler is giving me some errors. I have to make it a payable function, and then the compiler stops screaming at me. Yes. So yeah, as you've seen, this is probably something I'll cover later. So you can see that all it does is it. Yep, mappings are dictionaries. They're just dictionaries. So the keys are addresses. So you can see here I'm checking the balance of a sender. So this is how I access the particular value of this particular key. So what I'm doing is I'm getting some value, right? All I'm doing is adding, so I'm keeping track of the balance and I'm adding the balance, adding the how much ever the depositor sends to me as this balance. And just for the sake of completeness and usability, I'm also returning the balance of the particular user after he changes the balance, just so that the user can see like, oh, I've had 100, I deposited another 100, and now the function returns me a 200. That's it. That's all that's going on here. I'll come into this a little later. And then withdraw. So this is a function to withdraw a particular amount. So again, you can probably know why I have this require statement here, right? So I need to require that how much ever this person is withdrawing, it's within his balance. So if I have 100 ETH, I cannot withdraw 200 ETH, right? Because I never deposited 200 ETH in the first place. So this is a really cool, like, you can see how that require can be used to do all sort of cool things. So basically, I can only withdraw how much ever I have in my balance. If I try to withdraw, it will fail this check and it will throw, and then the transaction would have never happened. So I guess you can kind of understand how require statements are being used. So once it passes, that means I am successful. I'm withdrawing the money. So I kind of decrease my balance, but the money is still in my contract, right? Just by decreasing the balance, it's not like the money is going to go anywhere. All this does is it keeps the mapping, but the money is actually still in my contract. So what I do is I transfer the withdrawal amount from myself, the contract. So I pay the message sender this much amount. This is again syntax you must know. Each contract and actually all users also have a transfer function which we use to send money. So I'm just sending how much ever they want to withdraw back to them. And then again, I'm just returning just for the sake of them knowing the new balance. You know, when you use an ATM, you get to see the new balance, right? Likewise. And then there's a function balance, it's a view function, because it doesn't change any state. Here you can see that it's changing the state. Here it doesn't change the state, so it's a view function. It returns the balance for a particular user. So you can only see your balance. You cannot see others' balances because there's no balance function that takes in an address, right? It's just balance, and then it gives you your balance. So there's no way I can, pry into somebody else's balance because of the way this works. Okay, technically you can if you're a node running, but yeah, you cannot as a user. That's something else you need to know. And this statement is quite different from an if statement. Okay, so an if statement executes. So let's say I have an if and then a condition, right? And then I execute some code here, and then I have some other code here. So if the if statement is false, it will go to this code, right? So it will continue executing and it could possibly succeed. But a require function, right? Let me just clear this. So a require function with a particular condition, it does not execute the code. So if it's false, it just like throws and it's like, oh shit, he's doing something illegal or something like that. So it doesn't even run. It just exits. It breaks, it exits, it quits, anything you'd like to say. That's different. If continues the control flow. It continues execution, but the require does not. It quits. It tells the user that, oh, you have failed, the transaction has been reverted. And if you have a statement here, to be like, oh, it's reverted because of so and so. Yeah. So that's basically the contract. I'm going to just do this real quick. You don't need to understand it, but this is an overflow error. So if you have a really large number, like 4 trillion, right? You maybe won't be able to store it in a particular like UN256. So if you do like 4 trillion, which is the limit of a UN256 plus 1, it actually becomes 0. I know 4 trillion plus 1 must become like 4 trillion plus 1, right? But it becomes 0 because you cannot store. So you have to query check that it doesn't have an infinite balance. But then the reason it's being commented is because version 0.8 onwards or automatically checks for this, so you don't need to know that. But it's just something you need to know that UN256 integers can have overflow errors. Yeah. This is not necessary to know. It's just a thing. Yeah. Okay. So that's the contract. I'm going to go into deploying your contract and how you can even, in fact, set up the development environment. So I have my terminal here. So I'm using a tool called Truffle, which you can install by, it's a node package, so you can do it by saying npm install Truffle. I've already installed it, so I'm not going to do it again. So what Truffle does is, Truffle is a development framework for Ethereum. So it has like a lot of neat features like build, compile, so it can compile your contracts. Migrate, it's another one that run migration. So migrate is what you use to deploy contract groups. It's what you use to deploy contracts onto the network. We have some other things like testing and so on. So you initialize a project by saying Truffle init, but I've already done that. So when you init a Truffle project, you have migrations. You have this folder and the contract folder and the test folder. So the contract folder is where your contracts will be. The migrations would already be there for you. This is just to keep track of what you deploy. So these are the contracts that I have written myself. And the initial migration is something that will already be there. The admin migration is what I use to deploy my new contracts, the admin control of the bank contract. Tests, you can write your own tests, but I'm going to be covering that. And then you have a truffle.config, which you probably should use to declare the compiler version, maybe which network you want to deploy to. So if I uncomment this, I can kind of deploy to, I can kind of deploy to the Robston test network, or I can deploy to some kind of development network, a local network that's running, and things like that. So Truffle also has another really neat feature, which is the Truffle develop command. So what it does when I start Truffle develop, right? It creates a whole chain, a development or a test chain for you to just test, develop, and deploy and test your contract, interact with your contract. So you can see it has this chain. So it's a new blockchain, it's a literal chain like Ethereum that has 10 accounts and then the private keys for them, and then a mnemonic. So now you're inside a chain. So you can execute truffle commands. You can think you can do help, or there's no help. But yeah, so you're on the develop chain. So you can do things like migrate. So Truffle Migrate basically compiles your contract. So you can see it compiles admin control and then bank, and then it deploys. So it runs the script, the migration script. So it deploys the admin control and the NUS bank smart contracts. These are the contract addresses, how much gas I used to deploy the contract, some other things. So yeah, so these contracts have been deployed. So as you can see here, what I'm doing is this is again just syntax that you need to just use. So deployer is the deployer, so you can deploy the particular contract. So this is how I import my admin.sol contract or my NUS bank.sol contract. And then I deploy it by just saying deploy admin control and then the comma, and then I can pass in the constructor argument. So you can see that any admin control has a constructor, right, which takes in a list of addresses. So you can see on the deploy contract, I'm actually adding an address as the initial admin. So this is the kind of, how do you say it? The constructor argument when you first deploy, because you cannot change the stuff, right? Yeah, so once I deploy, I can get access to my contract by saying let's see equal to await the NUS bank dot deploy. So it's basically this is generally a JavaScript REPL, so you can execute JavaScript here. I think you can do 1+1 and things like that. But yeah, so now I have C, right? So let's look at what C has. So C has all the functions that my contract has, like like adding an admin because it extends from the admin, getting admins, deposit, withdraw, balance, and so on. Now, due to lack of time, I'm just going to execute the admin control commands for you to see, and then we can go to Web3, how you can integrate it to your website. So you can say like c.get admins. Get admins returns a list of users. The reason why we already have an admin here is even though we have passed in no admins is because if you look closely into the admin thing, it also pushes in the method center, right? So this address is actually the whoever sent the constructor, whoever deployed the contract, which is me. So if I go into my accounts .0, it should hopefully match. So this is my address in the test network here, and I'm the admin. So if I want to maybe, and by the way, the accounts variable gives all the addresses that you have in the chain. So let's say if I want to add an admin, right? C dot add admin. Is it add admins or add admin? That's my mouse. My mouse, yeah. I think it's add admin. Yeah. So add admin of maybe account 1. So you can see that when I call view functions, it just returns a result. But when I call a transaction, it gives me a transaction and then a receipt for the transaction, how much gas I used to pay for it. Oops. How much gas I used to pay for it, the logs, if any, and things like that. The contract address. This is the contract address. Yeah. Yeah. And now if I call c.get admins, I basically have both the addresses now. So there are 2 admins to the contract here. What is gas again? Yeah, so a gas is actually like the transaction fees that you pay. The transaction fees that you pay to execute code on somebody else's computer, because you're not executing the code on your computer, right? You're executing it on somebody else's, so you pay him to execute your code for you. So that's basically gas. So that's why when you transfer ETH, you have to pay gas fees, which is very notorious. I don't know if you've used the network, but yeah, that's just basically it. Gas is just the fees you pay. It's used. There are some like economics behind gas, but yeah, it's just the fees you pay for him to execute the particular code. Yeah. Ethereum good, or should I go to other chains? I don't know. It's up to you. What you want to do. I'm not gonna tell you that. All I'm gonna do is give you unbiased opinions on how to code. Yeah. Okay. As mentioned, ETH is quite infamous for us. Yes. Any way to get rid of this? Deploying. Okay. How to use a layer 2? Okay. Other blockchains like Solana but it uses a different contract engine, so we cannot deploy this. Okay? But the good thing about Polygon is it is EVM compatible. So what I can do is I can say, Polygon. I can add it to my Truffle config. So I have to have a provider, a network ID, which is all. Oops. So I basically I can do this, and then I can say, instead of migrate, I can say migrate to the Polygon network. If I had set it up, and then it would migrate, but then here it will probably say networks Polygon not found or something. Yes, unknown network Polygon because I haven't set the network up, but you can set it up. So that's how you deploy to other EVM chains. Like for example, Robston is not Ethereum, right? It's just an Ethereum test chain. But if I kind of do this, I can deploy to Robston. But here, when I type migrate, it's all it's doing is deploying to my local testnet chain thing. We got it, yeah. And then EVM, I've covered this before. EVM is the Ethereum virtual machine. It's the virtual machine that smart contracts and other things run on the Ethereum network, and some other networks also use the same chain, same EVM. So any contract that's written in Solidity can compile to EVM bytecode, and so it can be executed in any EVM chain. I'm just going to quickly go to the front end. I know we don't have time. I have 3 minutes, so I'm just going to like speed run the shit out of the thing. So this is a HTML page. I'm just going to start it up. So I have a contract here. In storage, all it does is it has storage, and then you can get and set data. That's basically all it does. There is an owner, but I'm not going to cover that because I literally have like 2 minutes left. Yeah. So I have the index HTML. So you can see that it kind of there's a CDN for Web3, I think. Yeah. So I'm injecting Web3. And then inside the like once it starts up, I'm kind of connecting to MetaMask. So just maybe I go back to the slides real quick. MetaMask is what we used to interact, like how you have to log in. On Web3 applications, you don't need to log in anymore. All you can do is use this kind of MetaMask, and it basically has all your tokens here. Yeah. Yeah. So just going quickly back into the code here. So when I start app, I'm adding the on-click to a get button that calls the get data, and then I'm adding another function here from the set button that calls the set data with the input and the from account, which is my account 0. So maybe I'm not sure which local host this is on. 887. So yeah, you can see that this is my account address. It fetched it from my MetaMask. So that's the actual address. So you can see here 0x blah blah blah. And then this is a contract address that I'm connected to. That also you can probably set up once you deploy. So you can see that when I deployed, I had a contract address here. Like replacing NUS Bank. So this is the contract address. So it's something I've deployed before, and then can get from contract, and then it gets to just what's probably stored in the contract. If I want to save a new number, which will be 3, set to contract, and then it should bring me up a MetaMask, because now it's not a pure transaction or a view transaction. So I need to pay gas for whoever is writing the code. So I say like, okay, I'm paying 0.0059 ETH. I confirm, and then it will run the transaction. And as somebody has said, it's notoriously slow. The Robson network is faster, but it's still slow. You can kind of see the like how the transaction is going on the Etherscan. It's pending. It will take a while to execute. So in the meantime, I can answer some questions. Which contract language should I learn first? And it depends on what chain you're looking to go into. But yeah, Solidity is the language that most people start off with, because it's much easier to wrap your head around than some other things and other languages. And Solidity has a lot of things to support, right? Like Ethereum, Polygon, all the L2 chains like Optimism and Arbitrum, and then like Binance Smart Chain, Avalanche, all these languages, all these chains support Solidity. So I would say Solidity is something you need to do. The initial migration.js and admin.js and Truffle config file will be automatically created when you run the Truffle init command. That's correct. Yes. So it will be automatically created. So we don't need to do anything. Truffle will handle that for you. You do need to change the Truffle config. So if I go to this Truffle config, right, I have set up my Robson test network config. So you can see that, oh, it calls a Robson in Furia. The network ID for Robson is 3. This is the gas I want to spend. So you do need to like type this out for whichever chain you want to deploy to. Like you can do the main net or the development or some advanced network or some other network you want to do. Yeah. So this is basically what you use to connect to the network. So that you might need to change. The migrations you don't need to worry about. Just add your contracts here and hit deploy. That's it. Yep. So so the transaction has succeeded. So I think if successful. So if I now query this to hopefully give me a 3. Yeah, you can see that the contract has changed in the tree. So I've successfully returned into the blockchain. Yeah. That concludes the workshop. So you can now ask all your questions. So should I set up my VS Code to have Solidity? Okay, I think both the questions are kind of similar. Yeah, so Remix is what people usually start out with, the Remix IDE. The thing is, right, it doesn't have a lot of different features. So there's this this doesn't have as many features as you would when you develop locally, right? For example, I have my local chain I can test out. I have a compiler. I can write scripts to deploy. So I can deploy differently. I have tests I can run. I can connect to different chains, different networks. I have this kind of weird debugger thing. I mean, yeah, it's the difference between using Remix versus Truffle local development. It's probably the difference between using like some kind of like hacker rank to run your C++ code or your Java code versus running it locally. So that's the difference. It's just more powerful, and when you have a big project with a lot of files to manage, really like a lot of files, and then Git, things like that, it becomes really hard. Like, look at this. What is this? I want to create a gist. I can't even push to my GitHub. I need to create a gist. So when you're more than one person, don't use Remix. When you're more than one person, just use Truffle, push to a GitHub so that you all can share code. Yeah, you should set up your VS Code to have Solidity if you, or whatever, you can use whatever IDE you want. I'm not going to force you to use VS Code, but just set up Solidity in whichever IDE you're using. Right online is called Remix. Yep, please use Truffle. It does seem daunting, but once you get used to it, it's super simple. So all you need to do is get used to this Truffle CLI. You can read up on what the different things are that you use to deploy. It's an alias to migrate, runs the migrations contract, compile says Solidity. Where's the develop again? Opens a console with the local development blockchain, so you can basically like type and interact with your contract. You can start off with Remix for like small contracts, but once you get into a team, and especially for the hackathon, use something like Remix or Hardhat, some tools that you use to develop offline. Yeah, smart contract has some checks in place to make it more safe. How these smart contracts are exploited? Just errors like, for example, let's say in the maybe the NUS bank contract, right? 31. Let's say in my NUS bank contract, I'm just a really bad developer. I forget to do this. Now what happens? So let's say I have 2 users who deposit 100 ETH and 10 ETH. So now the total balance of the contract is what? 110 ETH, right? But then let's say a malicious user who has 0 ETH deposited, he comes in and he says, I want to withdraw 100 ETH, right? Or in fact, 110. He wants to just clean the contract. He says 110 ETH. Even though the 110 ETH is not his money, he hasn't deposited it. Since we aren't requiring it, it will go through. This will probably do something stupid like make his balance a lot because of the overflow. But then, yeah, then it would send the money would send the money to him, right? He would be able to take all the 110 ether, even though he has 0 ether deposited. So it's just development error. Like you should be really careful while developing your contracts because they can be exploited. And when money is involved, you kind of want to make sure that you have like make your contract safe. That's why you have tests. I haven't shown you tests because we're already running out of time, but yeah. Oops, yeah. What's happened? You can rug pull a smart contract if you are using a proxy contract, but that's a little advanced. So I'm not going to talk about that here. It's going to maybe dismiss. Yes. Yeah, you can have smart contract rug pulls, so somebody deploys a smart contract and then they change the contract to do something else. Usually you can't. So that's the way smart contracts are designed, but there are ways to have a proxy contract that does things like that. Yeah. So I hope that's all the questions there is. We have exceeded our time limit by a few minutes. Yep. Okay, thank you. Thank you, Anon. This balance is an array. Arrays don't seem to be declared in the class. Balances is not an array, it's a mapping. So mappings are like, okay, I'll maybe give you a kind of a representation on how mappings look like. So a mappings is basically like this, right? So when it's initially it's empty. Let's say I deposit and my address is 0x123. Then I have 0x123 as a key. So this is the key, and I have a value 100. So I've deposited 100 ETH. And then maybe like somebody else has a different amount. So 0x124. Oops, 124 has maybe 200 ETH. So when I call balances, right? When I call balances of 0x123, it will return me 100. And then 0x124 would return 200. 0x124 would return 200. So it's a key value pair. So that's what a mapping is. It's not an array. It's a mapping, a hash map, a dictionary, whatever you use to in your other languages. Yeah. Are we able to see the domain name? So this comes under maybe deploying the front end, right? So to earn something. Okay, so maybe getting into ENS, so your own addresses and contract addresses are allowed to have ENSs. Yes, so you need to buy it from, I think, the ens.domains. I'm forgetting the ens.domains. So you can probably like get your own, where is it? Go to the app, and then once you're buying, maybe you want to buy this particular thing, you can register it, and then you can choose your another contract. You can, so let me take a look at something else. Maybe I think it's bought and like Vitality. Shit. Vitality. Oh my god. Okay, why talk? Yep. Okay, shit, it's available. So if I go to vitalik.eth, right, you can see that he already owns it. This guy is the one who registered it, but the controller is the same. So let's say I can register it for another contract. So now people can, as my contract as this particular thing. Yep. I'm 17 this year, studying IT in Poly. Do you recommend learning Solidity? Do I earn more as a blockchain developer? Okay, so in Singapore, I don't know. There are not a lot of blockchain jobs out there, but there's a talent crunch, right? So there are more jobs than there are people who actually know how to develop. So you have a lot of bargaining on your side. Depends on what you want to do. If you're working as a software engineer in maybe some other places, you probably will earn more as a blockchain developer. It really depends. I would say blockchain developers usually on par or a little more than software engineering, but depends on where you work. If you're working in a startup, you're going to get paid $0. So yeah, that's again, yeah, I don't know what to say. You can learn it, but yeah, it's better to be diverse, so you can you can learn a lot of things, be an expert in one thing. Yeah, I wouldn't say don't like ignore your other options. You can be a software engineer and a blockchain developer because you learn Solidity, but you know the other stuff as well. Address is a type that exists in Solidity. Yes, it is. It's a type that does not exist in other languages. It does exist in Solidity because addresses are very common in Ethereum. You know, like, oh, this is my address. And you know, I use it to interact. I use it to call other contracts. So address is a type that exists in Solidity. How do I have my career as a blockchain developer in instance where blockchain start off by making your own small contracts. A really good place to start is hackathons, like the NUS Fintech hackathon, which is Fintech Month Bybit hackathon thing that's happening right now. So please join that. That's how you can start your career as a blockchain developer, earn some money, then do more things, do complicated things, get some funding from VC or join a blockchain company or do open source contributions. There are a lot of ways to start your career here. Yeah. Yep, so it's 12:12. I hope that there are no other questions. I'll wait for maybe until 12:13. Yes, so just under 30 seconds. If there are no other questions, we can end the workshop. Thank you all for joining so much. Please join the hackathon. There are a lot of exciting prizes, and not a lot of blockchain hackathons happen. So especially in Singapore, there are a lot of blockchain hackathons, just not in Singapore. Then this is very localized. Nice, you can talk to your Singaporean friends. You can see who. Wait, it's not related. It's not actually in Singapore. There are some international. Oh my god, I missed it. It's a Southeast Asia hackathon or something. It's an international hackathon based in Singapore. So there are going to be people from outside joining us, but yeah, a very student-based hackathon. So please find that. Yep. No worries. Thank you.